one more thing you can do is that you could generate some secure addresses, cryptographically generated addresses. So what is a cryptographically generated address? So generally what happens is everybody has a public key, right? You don't have public key, but if you paid enough, you can get a public key, right? You can go to some companies that sell public keys, which is like a certificate. You can get a certificate from some place and say that, yeah, this is Raj Jain, or this is, you know, such and such. Now, if you, so you can, so that is associated with your address, and now you want to associate with some other address, and so this is the way. So they have an RFC which specifies how you can generate an address, and then you can still associate with your public key. So that way somebody can verify, yeah, this is you, because they have your certificate from before. All right, and so a node can generate an interface ID. So it can generate the 64 bits using the public key on the network prefix. So what you do is you take the home prefix, you take your public key and put a context which is a variable, hash all of it, take the first 64-bit, hash, and then end with this quantity here. Now this quantity is all 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, except there are 2 zeros here in the C. C is 12, 12 is 1, 1, 0, 0. So there are 2 zeros there. When you end, those 2 bits become 0. Everything else remains the same. And then you take the first 64 bit of the result, that gives you your interface ID. Why we zero those 2 bits? Because those 2 bits are universal and the group bits we talked about earlier. And so those 2 bits have to be zeroed. 0 means universal and 0 means non-multicast. Now this is somewhat confusing. Every time I teach this bit name, the name universal is just the opposite of what it's supposed to be. When it is 0, it means universal. All right? And the group bit, when it is 0, it means non-group. All right? For groups, that bit will be 1. For non-universal, that universal bit will be 1. So the names should be, one of the 2 names should be changed so that people can understand 0. 0 means should be local. So that is the local and the group bit. If the local bit is 0, then it is universal. So if that bit is 0, that is universal. So we zero those 2 bits. And mobile node can sign the binding update using its private key. So now with what happens is, with this method, you have a cryptographically generated address. You can use that address because your network prefix is foreign network prefix plus your CGA, and then you can sign it with your private key. So the way public key and private key works is that anything you sign with private key, anybody can verify it using public key. Public key is public. Everybody knows that key. So Microsoft certificate, all our computers have Microsoft certificate built in. So we know this is Microsoft, right? So similarly, there are lots of other addresses which are built into the computer. So we know that this is coming from that place. So if we have somebody's public key, we can verify it. If they sign something with their private key only they know. Okay? So then you can send a request, you can send a binding update which is signed. So then, that is an alternative to this return routability procedure where you don't have to go to the home address to verify you. This one works without a certificate, and that one requires a certificate. Okay. It is sufficient, but it's not necessary to use your MAC address as a part of your home, your host part. Okay. The reason it is sufficient is because once you put that, then you get a unique address. You don't have to ask anybody. Right? You could have DSCP, which is allowed. Right? It's not necessary. It is just sufficient. Right? So yes, you could give the same address. as long as it is not one of those MAC generated addresses. Okay. All right. So we understand that two ways to authenticate yourself. One is through the return routability procedure, and the second is to do this cryptographically generated address. And anybody can verify that this address belongs to this public key. All right. Third thing, okay, final thing is fast handover. Fast handover means that you could connect. I mean, it's like basically you could connect very fast. And generally you could even do make before break kind of thing. So what you do is you are moving from AP access point 1, which belongs to the router 1, which means this is a different subnet, and you are moving to access point 2, which is a different subnet, and its router is AR2. Right? So this is access router 1, access router 2, access point 1, access point 2. This is the mobile. It is going to move from AP1 to AP2. Now it will not know anything about the next subnet until it goes there and says, well, what is your subnet address, and give me an address, and so on and so forth, right? That would really break the connection. It will take a long time. So the fast handover is that you can ask that question from access point 1. Because you're talking to access point 1, before you go to access point 2, you could ask access point 1, who is the router for access point 2? Right? And if the access point 1 knows about fast handover, it will somehow ask somebody else and somehow get you the answer. So what it will do is it will say AR2 is the router and 2 is the prefix. Right? So this, by the way, the names below the lines are what we call the message name. So it will send a proxy solicitation whose English meaning is who is the router for access point 2. The real name is proxy solicitation. So it will send a proxy solicitation to AR1, sorry, AP to AR1, sorry. I'm sorry, it is not going to AP1, it is going to AR1. Who is this router for AP2? And it tells you the answer that AR2 is the router and N2 is the prefix. So the router is answering this. At the same time, the router will send a message to AR2 and say mobile wants an address, so that message is called handover initiate. And so the AR2 will send the response back to AR1, yeah, he can use or she can use address X. And then it will say, what address can I use? At that point, this already had the answer, and it will say you can use the address X, and then it can directly talk to, as soon as it moves to AP2, it can directly talk to the router 2 and says, well, I am address X, and now once this handshake is over, then they can start sending the packet. So basically, you don't have to connect to the router before getting the address. That's the point, is that your previous router can give you the new address, and it can give you the new address by asking the new router. So they have added these messages called proxy solicitation, proxy advertisement, handover initiate, handover ACK, fast binding update, binding ACK, fast neighbor advertisement, fast neighbor advertisement at ACK. So all these messages, once they are implemented, we say that this router implements fast handover, or this mobile implements fast handover. And in that case, when you break, you only have one round trip here. When you go to access point 2, your first round trip is this, and then you can start sending the packets. All right, so this is actually exactly what I have already told you. Let me just double check that there is nothing new here. Yeah, solicitation, advertisement with at least one prefix, and then it sends a message, AR1 sends to AR2, AR2 does the DAD. So that was one thing I didn't say, that the AR2 does check that it has not given the address to somebody else, and then it sends the address. So that is duplicate address detection, right? And then it gets the binding update, binding ACK, and mobile send the fast never advertisement, and so on and so forth. Everything else we have talked about. And it can also use CGA. CGA is the cryptographic generated address to avoid high and high ACK. So high is this last message, and let's see, HI, handover initiate and handover ACK. So this is where it gets the address, right? And the mobile can generate an address once it knows the new prefix. As soon as it knows the prefix, it can generate an address which is unique in that prefix for itself. So two more modifications. This is one, and the second one coming after this. First is hierarchical mobile IP. So hierarchical mobile IP is based upon again a solution to this whole round trip thing, triangular thing, is that if you are in a foreign country, you don't really want to talk to your home agent all the time here. So can you find an agent in that country which acts like your home agent? And so actually instead of calling them home agent, we call them anchor points. So you can find an anchor point in a foreign country, and that is, so you will have a hierarchy of anchor points, and that becomes hierarchical mobile IPv6. So this is mobile, and this is the regional care of address. So this is a regional mobility anchor point, and so it sends a binding update to the regional anchor point. It tells the agent locally that I am here. So this is the binding update 1, BU1. Then it also tells the home agent. All right. Now you will have a triangle, and it can also tell the binding update to the correspondent. If it sends to the correspondent, then basically, if you want to perform any kind of return routability procedure, you don't have to go to the home agent, you can do it right here. Or if you want to do CGA, obviously you don't need to do even that. So basically, you inform three people. You inform your home agent, you inform your local anchor point, a regional anchor point, and then you can also you can also inform your correspondent. Okay, so the idea is that you don't have to do everything through the home agent. You can do something through the regional mobility anchor points, and so that is called hierarchical mobile IP. Right, that's the whole idea. That's a regional COA. Second concept, which you will hear if you talk about mobile IP, is proxy mobile IP. And in proxy mobile IP, the hosts don't change at all. So they don't implement any mobile IP stuff. They just talk like if they are normal IP. However, the access points do all the work for them. So if you buy an access point and it says that this is mobile IP enabled, then they could be doing proxy mobile IP, where they would do all the registration and whatnot for you. So here is an example. There is an access point at home. When the mobile node is connected here, it is connected to this access point and talks to the router. When it moves, it talks to this other access point, and this also happens to be mobile IP enabled, actually PMIP enabled, which means proxy mobile IP enabled. When it goes there, and this one doesn't really know that I have moved, it doesn't know mobile IP, so it still uses its old address. All right. So this access point looks at the network prefix and says, well, this really belongs to WashU. This is not here. It has the whole world's database. All right. So it belongs to WashU, and it also knows in WashU who is the home agent. So it informs the home agent that this address is here, and then it does everything else that the mobile IP would have done. So this whole thing combined would become a mobile IP agent, basically. And so this will keep sending and receiving packets as if it was still at home. But this access point will change the addresses. So when the packets go on the network, they will have the correct source and destination addresses and whatnot. Okay? Now, not everybody can remember the whole world thing. Right? That would be just too much to imagine that every access point will know everything. So what we do is, we have some people know some things. So they just know a little bit, whatever is the cache, but there are some access points which know everything. So there is authoritative access point. This access point has all the information. So if it doesn't know about that one, it can ask the authoritative access point, and the authoritative one will look up its worldwide database and say, okay, here is the home agent for this network prefix. Okay, this is similar to DNS. In DNS, when you ask for a name to address resolution, you can ask your neighbor, they might know it, but if they don't know it, you go to the authoritative DNS, which resides right in the company where the address is located, and they will know for sure. Now, the reason I talk about proxy mobile IPv6 is because the cell phone companies are adopting IP. And when they adopt IP, they want to use proxy mobile IP. They have suggested that we will use proxy mobile IP. So the mobile IP is right now not used. As I said, we have discussed so much, but I have never seen one. However, the cell phones, when they start using this, then they will use this method where the cell phones themselves will not know what IP address, and they just use one IP address, and then the cell towers will take care of the details. So IP, we have already discussed all of it, but I'm just going to double check. IPv6 nodes have 128-bit addresses, the subnet part and the host part. PNIP enabled access point cache a database of home agents for all subnets that they support. Authoritative access point keeps the latest copy. All access point can ask the authoritative for the correct information. When a node connects to the access point, it looks at the subnet address of the mobile node. Who looks at? The access point looks at. And it realizes that this is from foreign network, finds the home agent, registers the address with it, and all packets coming to the home address will be forwarded to the access point. So basically, so even though, in that environment when this is implemented, we will not see mobile IP, but it is in the background. It's working in the background. Right now, I don't think this exists in the real IP network, in the sense that I have not seen the mobile IP advertisements and things like that, and so on. So anyway, that finishes mobile IP, and these are the 6 key points. First thing is that there is an extension header, mobility extension header, MH, and we talked about MH type 5, MH type 4. So in that, there are different messages, and then you can also do optimal route, avoid the triangulation by directly telling the correspondent, doing what we call binding update with the correspondent. You can do it securely using return routability. There are 2 ways to do securely. One is by using return routability procedure, and the other is your address itself can be verified by somebody else by looking at a public key that this is the address generated by this person. And then there is a fast handover, which allows you to get the new address before you get to that network. And again, there are 2 ways to get that new address. One is that you go through the router, and the router goes to the router and finds it. Other one is to just do the cryptographically address. Then there is hierarchical mobile IP. In hierarchical, basically you can make somebody local as an anchor point rather than going through the home agent for all these procedures. And then there is proxy mobile IP. In the proxy mobile IP, the access point do the job for the mobile. Okay. All right. So you can read about proxy mobile IP on the Wikipedia, mobile IPv6 on the Wikipedia. Actually, so these 3 are actually in addition, but not really required here. But there is a mobile VPN and VPN and proxy app. So anyway, so these 2 you might want to read, proxy mobile IP and IPv6 there. There is a document that I found on the net from Cisco, It's called Configuring Proxy Mobile IP. So Cisco implements it obviously, and then this document was really readable. And the Proxy Mobile IP slide came from there. These are the RFCs, mobility support in IPv6, Proxy Mobile IP, fast handover, Hierarchical Mobile IP. So those, the homework is to read 3775. 3775 is the first mobile IPv6 thing. So mobility support in IPv6, 3775. I want to make sure that you read it and make a list of 9 fields that are stored in the binding update list entries. So once you read it, then you will know what the answer is. Okay? And this is the list of the rest of the RFCs. You don't have to read any of them, but just in case if ever you do any work on that field, then you know what to find. And the list of acronyms. Okay.